Is it back up?
Instagram was back up early.
Okay, cool.
I was really bummed. I wanted it to be down forever.
I know. It would have been a good day.
I'm gonna show you some examples for like 2 seconds.
Yeah.
Funding this branch, about
Yes.
$7
How do we?
million value.
Oh, okay, never mind. It's just right there. I was gonna ask how we connect it to this.
Okay, so I have this one. Just use this one.
We don't have unity on this one.
No, yeah, I know we need to use this one. I'm just saying I don't actually know which one connects it to that.
Should we do the? Oh, should we host the Zoom on this? I guess we don't know. If we
Oh,
record it on
right,
this
I
and you're
kinda
screen
didn't
sharing,
think.
then you'll be good.
Yeah, I don't think it matters.
I can just give you guys like
Just press that
Zoom
button.
access from
Yeah,
my
that's fine.
computer as well.
Yeah, we can just, we'll make you host, and then since this is recording, if you're screen sharing on there, then it'll record. So we'll be fine.
It's a huge laptop.
Yep. Has a, what, a 1080 in it? 1080 Ti?
Yeah.
Big old graphics card.
No, it's not TI. It's just 1080. TI was too expensive when I bought this.
Still a behemoth. You can actually see
it's
the
actually
coils
like
in the
nice.
graphics card.
I don't know that I've ever seen this. Yeah, it's like due to the way the cooling system is just like massive. Yeah. Also can do this.
That's actually really convenient.
Oh my god. Just go.
Oh, you with me? I can just look at the camera because it's already here.
We want to talk about potential constitution.
But yeah, for sure. We were briefly talking about that earlier.
Let's see if this.
Yes, I appreciate you doing a little write-up on that, by the way.
I couldn't run all examples from PC, so I'm curious if I can make. There was a button here somewhere that shifted to it. Yeah, .com.
Yep.
Officer recall line up represents right up. And it's like, where are the meetings?
Yeah, anything that you scan on there will not
That's
be
actually harder to recall.
recorded, but that should be fine.
Oh, right.
That will-
I didn't think.
Will that be all right?
The
Like,
main
is that
reason
a
I
major
wanted
part
to
of what you're
write
planning on
that is
covering?
Because I
So the
envisioned
problem
a
is,
very
for
almost
example,
certainly never going to happen
I'm gonna
situation in
mute
which, like
the
all of your
microphone
officers are
for the time
friends
being.
and like each other.
Hey, so welcome back. Wait, hold on. Let me go ahead and screen share. Hello, Zoom. Okay, cool. So welcome back. We don't have too much to go over before the workshop, but it's just real quick. Of course, you've already heard me harp about it, but we have the fall break game jam coming up. We will have a kickoff for that at 6 p.m. in the room directly across from this one. The kickoffs, of course, is optional, but we'll be unveiling the theme, and there are a lot of energy drinks that we have that have been donated that are sitting in my room. So please come and take them from me. Also, we are going to have the Pico 8 workshop next week. So I've already sent out the link in the Discord, but there's the URL for it there. If you would like a free Pico 8 license and you are a dues paying member, all you need to do is put your Discord and username in that link, and we will get you a Pico 8 license so that you can follow along with the workshop, and it's a permanent license. So okay, yeah, that's pretty much it. So without further ado,
Get the license for free?
yeah, get yourself a free Pico 8 license, pretty please. We need to give them away. So I'm gonna give host to Nikolay, and we'll be good to go. You can do it. Well, this will have video, so.
Oh,
either-
but I'm not connected to that video. So your video will continue to.
Yeah, keep the microphone and video off on this, and then this will have you covered.
Okay. Okay, so hello everyone, my name is Snake and I'm a PhD student here at Computer Science and Software Engineering Department. And today I will talk about Unity, OpenCV, and generally using computer vision inside a Unity application. So the reasons I decided I am into this is that at my workplace, at my research, we are building an augmented reality application for a museum. And one of the tasks in that project was to recognize different objects in a museum and present some gamified experience to the visitor, museum visitor. That's why I decided that it may be cool to just present how we can include computer vision in a Unity application and maybe make some games from it. So I will shortly go through a couple of computer vision libraries and stop more on OpenCV.
I'm gonna try and fix the echo for you.
Yeah. You should be, yeah. I think it still echoes a bit. Anyway. Mine must be off. Yeah, my sound must be off. My audio is off.
It's definitely coming from over here. That doesn't make any sense. It's
Let
coming
me-
from a muted computer.
That's strange. Okay. Yeah, I don't know. I switched it on and off a couple of times and it worked. Anyway, so let me just go through a couple of other tools before dropping on OpenCV. So one of popular tools back in the days was XR toolkit. Said XR toolkit. Okay, for some reason it is not Googleable at all. Anyway, it was an old solution, so nothing much to bother about. So a lot of augmented reality stuff in Unity is done through AR Foundation and AR Core. So those are officially supported. AR Foundation on Unity. So it is like officially supported Unity library that natively supports AR Core on Android, ARKit on iOS, and also the two prominent augmented reality headsets, Magic Leap and HoloLens. So the cool thing about this application is that it actually gives a really nice positioning of your objects in a real environment. So, for example, what it does, it is able to track the room with a phone camera really well. And when the application starts, the initial location of your camera or of your mobile phone is taken as a 000 coordinate. And when it is able to track the coordinate system inside the room or inside some diverse environment quite well. The bad thing about this AR Core is about the AR Foundation. Sorry, I'm repeating AR Core because I'm working on Android. The bad thing about AR Foundation is that it supports not more than each of these native platforms support. And when things come to actual recognizing things in a room, that becomes a hassle because you are confined into either recognizing a plane, be it a floor or a tabletop, or recognizing a QR code, or recognizing a still image. So let me show really fast how will it be done. So first of all, AR Foundation asks you to include a couple of their prefabs. In Unity, prefab is a predefined object. You see that there is this AR session that manages the whole app session. Origin, which is like your basically, it's the 000 coordinate and the camera inside it. So the way you will try and recognize a QR code or an image with an AR Foundation is that it provides this image tracking controller. And inside that controller, you can actually list so which 3D object is triggered by which, so I will say image set, image database. So this image database is just a list of images. And what basically AR Foundation does, it tries to match each camera frame against one of these images. And if there is a good match, then it says, okay, I recognize this image, and it triggers your 3D object to appear. In reality, in the code, you can also track it yourself. It's a bit tricky. It actually, like inside the object that is triggered during when AR Foundation recognizes this image, there is a field with which you can understand what actually was triggered. But the downfall of this method is that it must be almost one-to-one match between the camera frame and the still image itself. So it may work on a QR code or on some like other type of marker. But when things come to actual like real life objects, like recognizing, I don't know, a face or recognizing a bottle, or in a museum, we must have recognized like objects like this, a human figure, or yeah. So at that moment, it is not enough because the visitor or your player, if it's like a real room environment, which you made into a mixed environment, this player can view the object from all different angles, and you may not just have a still image particularly for that angle. And that's where OpenCV comes into play. So OpenCV stands for Open Computer Vision, and it's a combination of libraries that allow different computer vision elements to be included in your application. So for Unity, there is the OpenCV. Oh, it's not. I forgot that. Yeah. So Unity has this OpenCV for Unity plugin, which is priced an ST $100. There is actually, it is based on, again, wrong keyboard. So there are, like, I think this is the most common. There are a couple of OpenCV wrappers around the OpenCV's like original libraries. So theoretically, you can also spend more time and use this wrapper and compile this wrapper into your Unity project. So technically, there is no need to pay like $100. You can also spend more time and work with the original OpenCV wrapper. So I will just, because I have the plugin, I will just run through a couple of things that OpenCV can do. And I will also present one really nasty thing, actual recognizing actual objects with OpenCV, because it actually took me a couple of months to figure out how to train OpenCV to recognize an object. There was a lot of obstacles. So also, I haven't tried much of these examples from my computer, so some of them may not work. And for some reason, Unity is very sensitive for actual data that is processed by OpenCV. So time to time, running on desktop, it may just crash. So yeah. So like a couple of minutes ago, this is actually the example that was on a screen. So, and I actually heard someone saying cool from the audience. So basically the idea of this example is that this is a very simple hand tracking tag. So what it does, it asks the user or the player to tap on an area inside the hand. And what it does next, it actually tracks the color of the hand, the color, and it defines like, but with the color, it defines the borders of your hand. And it tracks your hand using this, that it knows like the color of your palm, it knows about where it is, it knows like more or less its bounds, so it tries to track that data. As you see, for example, I removed my hand, it is still trying to find like something like my hand in the camera footage. So it is switching between like my head and my neck. So you can see that this algorithm is not ideal as using like a leap motion, for example, to track your hands, but still this is something that you theoretically can use. So another cool thing that comes out of the box, oh, again, wrong keyboard. So this one actually didn't work a second ago. Let me see. So, yep, this is what I was saying about. So this one crashed 10 minutes ago. Let's see if it will crash. Yeah, it didn't crash, but it's not recognizing either. It worked on mobile device, but not on desktop for some reason. And yeah, and similar to the AR foundation, it also can recognize still markers. But the real thing that I wanted to talk about is recognizing actual objects. So what you need in reality to today, what you do if you want to recognize an actual object, you need to train a model, neural networks model, to recognize, and that recognizes this object, and then use your neural network model. So the catch here is that training a neural network model from zero is not a good option because it requires a lot of images of your object. And for example, if you're recognizing like not a generic object like a table, but something very specific, then you obviously cannot produce a lot of images of this something specific. And there is a trick that you can actually retrain a neural network model. So to do that, first so the whiteboard will be visible, right? Yeah. So to do that, let me explain briefly about the neural network model. So basically, a neural network model, you can express it as a graph that has an entry point, an exit point, and each layer of this graph, of this neural network, it checks your input towards some criteria. So when, like, for example, Google trains their network on, like, for example, to recognize text, they have like thousands and thousands of text specimen to actually train their network. We don't. But what we can do is taking a ready neural network, removing last part, keeping all the rest, which already knows how to recognize, for example, images, and training it again, only like the last part, to recognize our specific image. So that can be done in a couple of ways. So today there are two like mostly used neural network libraries. One is PyTorch, which is a neural network library, which is a machine learning training library. And the other one is TensorFlow from Google. which also can be used for machine learning, and both of them can actually retrain your model. So, and TensorFlow actually provides a way to do that. So this code actually is straightforwardly copied from Google's example, and what it does, it just downloads the some like ready big neural network recognition model that recognizes images. In my case, I think in my case, it's MobileNet V2. So basically, like, this is very generic model, and it is able to recognize a lot of different real-life objects. So what this code does, it actually takes this MobileNet V2 network, it removes a couple of layers on the top, and it trains again on our specimen. So, for example, in my case, everything what I need to do was just, so actually Ezra suggested to do this. I just took a video of an object that was my interest, for example, this pottery. And then from the video extracted a lot of images. And that became my training specimen. And instead of, like, because this training specimen, all of them look like each other, it's not like you cannot really train a neural network with this, but because we already have like a pre-trained neural network, we can just retrain it using TensorFlow. So the trick with TensorFlow was, and which actually took me this like couple of months to figure that out, because apparently there was no answer on the internet. Crazy thing, you couldn't find an answer on the internet for the first time. Is that Unity apparently, before proceeding, so when you train a neural network, you can actually export it. And the way it is exporting, this is like this PB files, right? Which is like what you're exporting towards. And apparently there is a trick that because we are changing a couple of upper layers of this neural network, Unity, for some reason, does not recognize it. It cannot work with it because in its eyes, this is some fake network which is not fully trained, and it cannot work with it. And apparently, what was required to do was specifically when saving, telling the TensorFlow to freeze the whole network. So basically no one can use this network anymore to train anything, but Unity is okay with that. Unity, now Unity understands that this is like a finalized network and it can work with it. So in Unity itself, what happens is that you need to provide your TensorFlow model, your neural network model. And besides that, there is also another thing to be provided, which is a text file containing labels of your objects. So for example, in my case, wait a second. Come on, I know that you're here. Yeah, so it's just a text file with all the names, like labels of objects in the neural network. And there is actually a funny thing that TensorFlow does not give you such file. So literally what I was doing, so what it gives, it actually gives you an index of an object it recognized, but not the name of the object. So literally what I was doing, I was hovering my phone over like an image of artifact and seeing which index it gave. Okay, if it gave this index, probably this index is this actual like model name. And what OpenCV actually provides is it provides you with this min-max object with which you can understand what was recognized. And so the way things are recognized in TensorFlow model, it does not specifically tell you that, hey, this particular thing was recognized. What it does, it says that, hey, you know, index 0 was recognized. Maybe it's index 0, I'm giving like 50% accuracy for that. Maybe it's index 1, I'm giving you 60 accuracy for that. And what you should do, you just need to take maximum of the accuracies, and that will be the index you need to use. It will be the model you need to use. And also you need to have a minimal acceptable accuracy level. For example, if you are, in my case, I think I put 60%. No, actually, sorry. Yeah, it must be 6 here. I was trying some things. Yeah, because like at most my models were recognized at about 70% accuracy. So for me, 60% accuracy recognition was a great thing. And that's basically it. That's how technically in just a couple of hours you can make TensorFlow, using TensorFlow and OpenCV, you can actually recognize an object. And oh, sorry, it's still face detection. So you can see that in this case, come on, don't shame me. You must recognize him. Yeah, you see that still it tries to recognize other things as well. So that is actually something that you need to tune a lot. For example, a way that I was kind of thinking to, yeah, for example, a way in your game, if you don't have like 100% accuracy in your model recognition, one thing you can do, for example, is asking the player to click a specific button to start recognition, and then record camera footage for example, a couple of seconds, and just check which object was recognized the most. And for example, that is another solution that can allow you to recognize objects having very little like specimen to train like actual neural network model that will give you more accuracy than you have. So this is basically what I wanted to present, and sorry if it came a bit messy. I will provide Ezra with links on like the steps I took. So if you want to try it yourself, you will be able to try it yourself. The only obstacle is the OpenCV library. You can actually download it for free as well, besides paying, but of course not from the official asset store.
All right, so that is pretty much everything we have for this week. So you know, reminder to pay dues and all that if you haven't already done that. For those of you who are in person, you can stick around after for a little bit and we'll be able to see the demo of the computer vision model that you just saw with a built mobile application, which may or may not work a little bit better depending on how the library is feeling today. So that is pretty much it. Hope to see a lot of you guys at the Fall Break Game Jam. That'll be Thursday at 6 p.m. And hope to see you guys as well next week. Don't forget to request those Pico 8 licenses if you want a license to participate in the workshop or if you just want a Pico 8 license. So thanks for coming out, everyone.